Hello, this is Mr. Huber. In this lesson, we're going to look at dividing polynomials using synthetic division. This is a little bit different process than long division. Some might find it a little easier. One of the keys, though, is it can only be used when we are dividing by something in the form x minus k. So if there's an x squared, x to the third, something else, we're not going to be able to use this. But when it's x minus k, we can use that k value. Okay, we can use the k value right here to set up our synthetic division along with the coefficients of whatever polynomial we're dividing into. Here are the steps on the screen we're going to follow. I'm going to go through the process. If you want to refer back to this, use this as a guide as you're going through and doing this yourself. We'll see how this process works using that k value and the coefficients of our polynomial we're dividing into. So we have an example here. We're dividing x to the third plus 4x squared minus x minus 1 by x plus 3. So we could set up long division and it would work as well. It's not that that method doesn't work, it's that there's another method we can use here. So what we're going to do is we're going to take that k value, in this case minus 3, because it's x minus k. So keep in mind it's the 0, if you will, of that dividend. Okay. So now the minus 3 goes there. We're going to have inside this upside down division sign a 1, a 4, a negative 1, and a negative 1. So that's our coefficients: 1, 4, negative 1, and then our constant term negative 1. And what we're going to do is add the first column. There's nothing in the first column to add this to, so we're going to bring it right down, add it to 0 essentially, and it becomes a 1. Now we're going to multiply. Okay, we're going to multiply negative 3 times negative 1. Okay, we're going to multiply those, and we're going to get negative 3. Now we're going to add again, right? We're going to add going down this way. 4 plus negative 3. 4 plus negative 3 is 1. Then we're going to multiply by negative 3 again. So negative 3 times 1 is negative 3. Then we're going to add and get negative 4. Negative 3 times negative 4 is 12. And we add here, we're going to get 11. So the way this works is those numbers we have here are the coefficients of our quotient. And this is the remainder. So what that will look like when we rewrite our final answer is we're going to have 1x squared plus 1x minus 4. We'll talk about that 11 in a second. So 1x squared, 1x minus 4. How do we know what to start with? Well, we are dividing x cubed was the lead term of our original polynomial. This is going to be 1 less than that. Okay? And we should get an x squared, x, and then constant term. Right? If we don't end with a constant term, that would be a sign that we maybe put the wrong variables in here as well. So 1x squared, 1x minus 4. And now the 11's our remainder. There's a couple different ways that's written. I'm going to show you both of them. One, we can just write with a remainder of 11. Okay, R for remainder 11. That would be one way to write this. We could also write this as 1x squared plus 1x minus 4 plus 11 over x plus 3. When you divide any numbers, that remainder would go over your divisor and then as the remainder a fraction. Okay, so keep that in mind. That's just like you divide any other time you're dividing numbers. If you had 10 divided by 3, right? So we set up 3, 10, goes in there 3 times, it's 9, remainder 1, so 3 and 1/3, right? We take this right here, the remainder, and it goes in the numerator, and then what we were dividing by was 3, goes in the denominator. Here the remainder is 11, so the 11 goes right up here in the numerator, and then what were we dividing by? X plus 3, that goes in the denominator. No different than what we see here. Okay, we do the same thing up here. So a couple different ways we can write that final answer. Let's see a couple other examples here. And maybe you try one out here after we pause for some prime time. Okay, what's the smallest prime number? So what does prime mean? Okay, when we talk about a prime number, we're talking about a number that has 2 factors, 1 and itself. So what's the smallest number that has 2 factors, 1 and itself? So something like 5, for instance, is a prime number because its factors are 1 times 5. Those are the only factors that will give you 5. So you might be thinking, oh, 1. 1 might be the smallest prime number. 1 equals 1 times 1, right? But 1 is actually not a prime number, a little bit of a tricky situation. It doesn't have two factors. It only has one factor, 1 and itself. That's not a different factor. So 1 only has one factor, so the smallest prime number is in fact 2, which has factors of 2 times 1. So 2 is the smallest prime number. A little bit of a tricky question. A lot of people will often guess 1 on that one. Okay, but 1 is not a prime number. Let's see another example of synthetic division here. And maybe you could pause this, try out the problem yourself, press play as it goes through, see if you are in fact setting this up correctly and fully answering it correctly. So we're going to have minus 2 here, because again that's the 0. X plus 2 means we're going to have a minus 2 outside there. We have 1, negative 14, 51, and negative 54. Okay. So when we start this out, right, we're going to bring the 1 down. That's 1. Negative 2 times 1 is negative 2. And then again, remember, we're going to add these columns. So negative 14 plus negative 2 is negative 16. And then we're going to do negative 2 times negative 16 is 32. So keep in mind, right, when we're multiplying here and here, we multiply these together and gives us the 32. Okay. Now we're going to add 51 and 32 is 83. We're going to multiply by negative 2, that's negative 166. And now when we add these together, right, a negative plus another negative is going to be more negative, so negative 220. Negative 220. Okay, and so now these are the coefficients in our quotient, and this is our remainder. So what would that look like when we write it out? Right? We're going to have a final answer of x squared. You don't have to write the 1 in front of it. You can, it's not wrong. Minus 16x plus 83, and then remainder negative 220. Okay? Or you could write this as minus, because there's a negative there. So negative 220 means we're going to do minus 220 over x plus 2. So you can write that remainder either way, it would be acceptable. Okay, and it's good to know both formats depending on how you might see it. So again, to use synthetic division, we're going to put the negative 2 here because we have x plus 2. So negative 2 is the 0. Then we're going to write the coefficients 1, negative 14, 51, and negative 54. 1 plus 0 is 1. Then we multiply. Negative 2 times negative 1 is negative 2. Then we add negative 16. Multiply by negative 2 gives us 32. Add, multiply by negative 2, and add. All right, so that's how we can use synthetic division here. And one more example for you to try out. After you set this one up, pause it, set it up, then press play. See if you've set it up correctly before you go through and do the whole problem. Okay. So hopefully, if you've set this up right, we've got a 2 here. And then when we write down our coefficients, we're going to put a 3. And this has a plus 0 x to the third. So plus 0 x to the third in here. It's not written in there. So we need to include that 0 as one of our coefficients. Then we're going to have negative 8, negative 11, and 1. So it's important here, with no x to the third in here, there's a 0 x to the third. So we have to include that 0 for the coefficient in front of x to the third. Now we can perform the synthetic division. Bring the 3 down. Times 2 is 6. Add there, we get 6. Times 2 is 12. Add, we get 4. Times 2 is 8. Add, you get negative 3. Times 2 is negative 6. Add, you get negative 5. So now when we write out our final answer, it's going to be 3x to the third plus 6x squared plus 4x minus 3, and then remainder negative 5. Or 3x to the third plus 6x squared plus 4x, and then minus 3, and the remainder minus 5 over x minus 2. So keep in mind, right, these parts here are all the same. How we write the remainder can look a little different. Okay? Same process for setting it up, but remember, if there's no term in there, with in this case an x to the third, it's a 0x to the third. So you have to include a coefficient for every degree from your leading degree all the way down. If anything's missing, fill in with a 0. Synthetic division, again, only works when we have an x plus or minus that we're dividing by, and then we can use that 0 to set up our synthetic division. Careful with the process there and how to write the remainder, and you should be good to go. And this can be a method we'll see as well that can be used for other things in terms of helping us with factoring and some other situations down the road.